idea is going to be called normal approximation. It's just a procedure that we would like you to know it. If you want to get more serious courses in statistics, then you will get to this. Normal approximation to the binomial. And with this expression, the problem would be given to you later on the test, okay? To the binomial distribution. You have to design the problem. At the end of the day, it's just a CS score and the thing that we did before. Now, what's the problem? You see, let's recall what we know so far. Recall that the binomial distribution, you see, the binomial distribution formula, you know that is, and let's write it down for the last time. It's a P of R, probability of success, is equal to the n factorial, n minus R factorial times R factorial, P to the R, Q to the n minus R. And this would happen when this R, the number of successes, can be equal to the 0, 1, 2, up to there. You see, that's a formula for the binomial distribution. Okay, remember the n is the sample size. Now, if this n is large, it's not possible, it's not practical to be able to do this one, unless you have a very good calculator. By large, I mean n equal to this 1 million, for example. You see, if the sample size, the table that I gave you just goes up to the 20. Remember, if the sample size n is very large, if it's going to be very large, then it is not practical. It is not. It is possible, you know, of course, but just using a good calculator. But it's not practical mathematically to use the formula. Okay, to use the formula. So what we can do is, the proof is very nice. It's not difficult really. Need a little bit of calculus. So what we can do is it can be proved, or it can be easily proved really. Sometimes I prove it. So it can be proved. It can be proved that if n is large enough so that these two conditions satisfy. The first condition is n times p must be greater than or equal to the 5. You know that the p is probability of success, n is the sample size, and n times q to be bigger than or equal to 5. This is going to be the condition that that we need for the normal, for that approximation. So it can be proved that if these two satisfy, and the reason is when we want to prove it, we arrive at these two numbers as a cut point, if you like. So it can be proved that if these two conditions both together, if these conditions satisfy, then the curve. Remember, the curve of the binomial distribution is a histogram, dot, dot, dot. But the curve of a normal distribution is just a bell-shaped curve. It can be proved that if this happens, then the curve, I mean histogram, of the binomial one, of the binomial distribution okay can be covered, can be approximated by a normal curve, by a normal curve. You know that the normal curve is a Z curve, bell-shaped curve. You see, this is the situation you're going to have. Just give you an idea. So when these conditions satisfy, and you are going to have the histogram of the binomial. Remember, the histogram was a connection of some towers. You see, this is going to be a situation you're going to have in this case. These are going to be the graph of your binomial case. See, if these two conditions, this is going to be the histogram for the binomial. But what we can do is we can use a little bit of calculus to cover this. You see, we can cover it. We can cover it by a curve, by a continuous curve. And that curve, of course, is the normal distribution curve. That's why we call it approximation. Okay, so this is the histogram, the binomial case with these two conditions. Then mathematically we can cover it, we can approximate it by the normal curve. Okay, so now we were in a binomial, then drop it into the normal. So the resulted normal curve, the resulted normal distribution, you know that anytime you say normal, I need the mean and I need the standard deviation. So the resulted normal distribution will have a mean of, you know that you did it on the quiz, question number 2. Remember, the mean in the case of the binomial, mu is n times p. So this is going to be the mu in the case of the normal. And the standard deviation, and the standard deviation, sigma. You know that the sigma, again, you did it on the quiz. The sigma for the binomial is the square root of npq. You see, this is what we did. So you have a binomial case. You check these two conditions. If these two conditions satisfy, you are going to say that, oh, the approximation is possible. When you say approximation is possible, you have to find these two, mu and the sigma. So now you are in a normal case. Then you go and you find out what was the question. The question is going to be this. Remember, probability that R is less than 2, bigger than 2, etc. So in this case, what you have to do is, there is something else that you have to do. The difficulty is going to be, in the case of the normal distribution, when we talk about the probability, we're using the probability of X. X is going to be, you know, that area to the right, to the left, less than, greater than, in between. It's going to be an intervals. But in the case of the normal, it's not. You see, in the case of the normal, when you want to find the P of R to be equal to 12. So that would be 12. The next time is going to be 13. So what you have to do is, you have to drop that R into an interval to be able to do the next part. Just explain it, then I'll tell you how we're going to do it. So that would be the next step. The next step is going to be, the original variable is R. Note that the variable R in the binomial case. in the binomial distribution. Okay, R in the binomial distribution is discrete. You know that. It's a dot, dot, dot. Okay, it's discrete. Whereas the variable in the normal, we use the two different notation. Whereas the variable X in the normal distribution, in the normal distribution is continuous. It can come with an interval only. Okay, in the normal distribution is continuous. So you have to modify this case to be able to do it. See, in the first part, for example, so in the first part, what you have is, you see, in the first part, this is going to be the first part. In the first part, you have the R. You see, R is here. So you want to find the probability that, you see, R is equal to the something. If you like an example, you see the example that you are going to have is this one. You see, suppose R is equal to 2. If you want to find the probability that R is equal to 2, that's a binomial. But if you want to do it in the case of the normal, in the case of the normal, you can do it if you just find an interval of the two. Because the z-score, you see the z-score is the area, So it must be interval, remember, from negative infinity to the 5 or 5 and positive infinity. So we usually do is we are going to make an interval around the 2 or around the R over here. Let's try. Can you give me an interval containing 2? Interval containing 2. You have to go a little bit to the right, to the left to get that interval. Okay. Let's see. No. Interval, Jennifer. An interval means, you see, 0 interval from 1 to 10. This is an interval. Interval from 0 to 5. It's an interval. You see, this is 2. So what you do, you have to pick a number to the right and a number to the left to get an interval. Okay, so for example, this is 2. If you pick the number 3 here, between 1 and 3, you see, between 1 and 3. So interval between 1 and 3 would cover 2. So that would be one choice that we can get. Yes, 1 and 3 is one of them. Anything else other than 1 and 3? Anybody can give? Give us an interval containing the 2. Something like 0 and 4. Yes, 0, 4, 1. Anything else? An interval containing 2. Pick a number to the right of the 2, number to the left of the 2. That give you the interval as 2. Okay, yes. 1 and 5. Yes, Bill. They're all correct. Yeah, as you can see, there are many choices. There are many choices that you can get from the right and the left. So what we are going to do, we are going to pick one interval so that everybody will use that one. The interval that we're going to use is, this is the number is given to you. We go to the right only as much as 0.5, and we go to the left as much as 0.5. So the cut would be 0.5. You know, it's like when you want to, what's that, round the number, less than 5 and bigger than 5 differences. So what we are going to do, we are going to introduce an interval, so everybody would follow this one. So this is going to be R. So suppose you go to the right, how much? As much as 0.5. So it's going to be R plus 0.5. R plus 0.5. And you go to the left over here, how much? R minus 0.5. You see the interval that we consider is going to be the interval that we are going to consider is going to be r minus 0.5, comma, r plus 0.5. So if the question was find the probability that r is equal to 2, when you drop it into the normal, it's going to be probability that x would be less than 2.5 and greater than 1.5. Then you go to the z-score, you find the z-score formula, and then you do that. This operation is going to be called correction for continuity. So this means in the case of the binomial, you have the number, but you change it to the to an interval. And this is a part that unfortunately most of you are going to miss it on the test. Some people they don't correct it for continuity. So this means I'll just explain this last expression. So if you like this procedure that we did, so we must apply, if you like, we must apply this operation is going to be called must apply the correction for continuity, we call it. The correction for continuity. Continuity, I'm going to call it CC. Correction for continuity. Okay, for adjustment, if you like, of that idea. Or adjustment of the variable. Because you change the variables. Okay, so you go from a discrete numbers, dot, to an interval. Okay, so this procedure is going to be called correction for identity. And this is how you're going to do it. There are going to be 3 cases. We give all the 3 cases, and then you can use it right away. Okay, any question? So that's the main part. When you do the approximation, you have to change the interval that we have. So that we finish it, then I explain it for you again. So as we talk about it, we are going to consider, everybody should consider only this interval. We consider what? The interval. Interval is going to be r minus 0.5, comma, r plus 0.5. Okay, for the correction of continuity. Correction of continuity. So that's the important part. You are going to have following cases. You see, you get 3 cases. So I give all the 3 cases. You can use this table. Use the following. Use the following table for CC. So the cases are going to be that you're going to have. So look at this one. So this is going to be the question in binomial. And this is what you are going to use in the case of the normal. In a case of the binomial, you may be asked, find the probability that r is equal to a number, is equal to the 2, 3, 4, 5, 6. If this is going to be the question, you are going to change it to the finding the probability that, you see, remember 0.5 to the right, 0.5 to the left. So you're going to use, answer this one, a minus 0.5 less than x less than a plus 0.5. So this is the original question. You change it to the normal. This is going to be normal cases. And you know that this is, you find the z-score and you get the probability right away. And that's when they say exactly, find the probability that exactly 5 people of the class, would have that in the case. The other one is going to be probability of at least. In the case of the binomial, if say at least means bigger than a, then you're going to change it into it's going to be x bigger than, you see, you see the same notation. Now, this is a, you see, you want it to be bigger than. A is bigger than what? A can be bigger than these two numbers. It's going to be bigger than A plus 0.5 or A minus 0.5. It's going to be bigger than A minus 0.5. When I do it with a number in a minute, you will find out. And if it's going to be the other way around, means if it's going to be at most, then you're going to have the probability of X to be less than what? You see, this is A. A would be less than, when we write down as an interval, A would be less than the bigger number. So it's going to be less than A plus 0.5. That's it. That would be correction for continuity. You correct for continuity, and then you go to the Z table, and then you'll be done. That is the procedure of the normal approximation to the binomial, which is great, great. Mathematically, this is something quite interesting. So let's do it to get to know it, the procedure. It would be better understood if you just do it with an example. Okay, are you ready? So in the example, the sample size is going to be very large, and you are going to be told that the normal approximation to the binomial means don't try to use your calculator to get these numbers. Okay, that's it. I'll give you one example on the next test number 3, and one on the final. This is it. The situation is we are going to be told that the probability, we did this problem before, but we did it for a sample of 4 people. Now we're going to do it with the big sample size, okay? So the probability that a person, remember that a person age 20, okay, will be alive at age, okay, at age 65 is something like 80%. Okay, we consider this one as a probability of success. So what's the question? The question is, we are going to pick, suppose, you see, suppose 500 people. You see, that's a sample size. Suppose 500 people, age 20. Age 20 are randomly selected. Randomly selected. So what's the question? The question is find the following probability. Determine the probability. Determine the probability that, I'll give you all the 3 cases that we have over here. Usually give you one. The first one, finding the probability that number one exactly, that's case 1, exactly 390 of those 500 people, of those or of them will be alive at age, okay, age 65. That's the first case, that's exact. The second one, the case, second one is going to be at least 375 of them will be, okay, will be alive at age 65. And they are going to give you the instruction that you have to use these ideas. Use normal approximation. normal approximation to the binomial distribution, to the binomial distribution. So this means you should use this method, not a very good calculator. Okay, so you got to be careful. This problem takes a little bit time because you have to show us all the details when you're being asked to do it. And sometimes we ask only one case A or case B, but it's fine. We can do it even with the two cases. Okay, there you are. Solution. First, you start with the binomial case and collect what you have. You know that this is probability of success is going to be success is when the person can be alive. So the P is 80%. Okay, that's it. That's going to be P, and Q would be 20%. The sample that we have, the sample size is 500. So identify this. So we say that it's a binomial distribution. It's a binomial case. It's a binomial case with binomial information. P is equal to the 80%, which is 0.8. And the Q is equal to the 20%, which is 0.2, and sample size of 500. We did this problem before, but the sample size was 4. And it's going to be huge. Okay, the first thing to do, you have to check the condition. Remember, condition is n times p must be bigger than 5, and n times q must be bigger than 5. So first thing to do, you have to check these conditions. That's step 1. Okay, step 1, we check n times p. N is equal to the 500, and this is 0.8. You multiply them together. 5 times 4 would be 4,000. We have from decimal, so it's going to be 400. It's bigger than 5, so it's satisfied the first condition. You have to check the second condition. The second condition was n times q. N times q, n is 500, and the q is 0.2. You multiply them together, that give 1,000, 1 decimal, 100 bigger than 5, so you are okay. Okay, so you claim that the normal approximation is possible. The normal approximation, can be applied, or it's possible, can be applied. As soon as you say normal can be applied, so you know that in case of the normal, you need a mu and you need a sigma, because each normal distribution would be characterized by these two quantities. So mu is n times p. Remember, you are still in the binomial case. So the mu is n times p, and you already got this number. Is a 400. So that's going to be 400. A standard deviation, you have to find it. For the binomial distribution, it's going to be a square root of npq. Substitute. It's going to, the first one is going to be 400. If you want to, you can use it. But I repeat the formula: 500, 0.8, 0.2. Okay, if you use your calculator and take the square root, that should give you 8.94. Double check it, because these are the numbers that's going to be very, very important. Okay, so now we are out of binomial case. So you have a normal case with the mu equal to the 400 and the sigma equal to the 8.94. Now you bring the question. The first part is probability that exactly 390 people were alive at the age of 65. So let's go to the next page. Any question? So nicely, check the first condition, then you drop it into the normal. From now on, you are in a normal distribution case. Okay, so what is the, so I just remind myself that the mu, I need So the mu is mean is 400, and the sigma that you're going to take for the rest of this problem is going to be 8.94. Now you pick the question. What's the question? Question the first part. You see, they ask you exactly what's the probability that exactly, okay, 390 people leave after 65. So it's going to be probability of R. You are in binomial. R is equal to what? 390. You see, this is where you have to correct for continuity, change the R into the X. So you have to do the CC that we talk about it. Okay, this is the one. So that's a question. So you have to change it. CC. For the CC, it's going to be probability of, you see 390 exact numbers, 0.5 to the right, 390.5 minus 0.5, 0.5 to the left would be 389.5. So variable X, I write it down, it's going to be 390 minus 0.5 less than X less than 390 plus 0.5. So the conclusion is going to be probability that X is going to be between 389.5 less than X less than 390.5. You see? So this is the question. At this level, you can use your calculator to get it. I'll show you later. Rather continue, give you the result, and then we can use calculator. You see, the calculator can be used only for this. You have to give us all the formulas. You cannot just give us a number. So if you want to do it as is, you know that you have to find the z-scores. Okay, find the z-scores for these two numbers. We're going to call them x1, 389.5, and x2, 390.5. So you know the formula for the z-score. So there you are for the first one. It's 389.5. So the z-score formula is x minus mu over sigma. Substitute. So 389.5 minus mu is 400. Sorry, yes, 400. A standard deviation of 8.94. 8.94. Okay, you can use your calculator. The number is negative 1.17. 2 decimal places for the Z. Okay, any question? Go back, check the second one. The second one is x2. X2 is 390.5. So the Z formula is going to be x 390.5 minus 400 divided by 8.94. Again, if you use your calculator, that gives you negative 1.06. Okay, so the probability in question now is going to be probability that Z is going to be between negative 1.117, okay, less than Z, and less than negative 1.06. Okay, so get the graph and the table and get the numbers. So you have two negative numbers. Suppose this is going to be negative 1.17, and this is going to be negative 1.06. You can use your table to get these numbers. Okay, negative 1.17 from the table is going to be 0.1210, and for this one you get 0.1446. You subtract it. Okay, if you subtract these two, so it's going to be 0.1446 minus 0.1210, and the result is 0.236. So that gives you 2.36%. So the probability that exactly 390 people would be alive at the age of 65 is almost 2%. I mean, 390 out of those 500 that we did. Okay, any question? So that's a first case. If you want to use your calculator, you have to go up to this one. You have to do the correction for continuity. Okay, you do the correction of continuity and you know that. Then you can bring the idea that we talk about it. Just get the second. Go to the normal CDF. That's a normal CDF. Okay, the area on the top and the bottom. The lower area is 380. Okay, this is 389.5. Then the upper is 390.5. Okay, and the mu is 400. And the standard deviation is 8.994. Okay, so we're going to paste it and then we're going to find it. That's it. 0.02387, 0.0239. See, that's exactly what we got over here. We have a 2.36. It's a little bit different, but you have to check those operations that we have. So as you can see, you can do it with your calculator, but as I told you, you have to do the correction for continuity to get the problem here. And you have to write all this in symbolic form for us. When we get to this part, you write equal to, you just give us the calculator, we accept it. Okay, and otherwise we can do it. But if you just give us a number, we don't accept it because you have to connect the numbers with whatever we did. Okay, any question? So your extra job really is that correction for continuity, not to miss it. You cannot use 390. You have to check it. Okay, you correct for continuity, and then the rest is going to be kind of normal distribution. Okay, that's for the exact. Let's do the part 2. Just make sure you know how you take care of the at least, at most. You must make sure that you are not going to miss that. Okay, that correction for continuity. So the second part, I go to the next page because I need more room. You see the second part, again, you write it down in symbolic form. You want to find what is the probability that at least the beginning, 375 out of those 500 people are going to be alive at the age of 65. You have to correct for continuity. You see correction for continuity, CC, it's going to be P of, this is R, you change it to X. X greater than what? You see, this is 375. The choices are what? 0.5, you add 0.5 and you subtract the 0.5. So 375, you want it to be greater than, you see, greater than. 375 is not greater than 375 plus 0.5. Is greater than the smaller number, 374.5. And I've already given you the table. You see, you can use the table if you like. You see, this is going to be probability of greater than, and that give you A minus 0.5. And if you just use common sense, you will see it. You want it to be greater than, so it's greater than what? Is it greater than 375.5 or greater than 374.5? Of course, 374.5. I write it down so that you know how we find it. It's going to be negative 0.5. So you have to find the probability that X is going to be greater than 374.5. So that would be the question. Okay, any question? So you have to correct for continuity. Now you know that you have to find the Z-score. At this level, you can use the calculator. I'll show you later. So it's going to be x equal to the 74.5. You get the z-score of x minus mu over sigma. We substitute. Your x is 375.5, the mu of 400, and the sigma of 8.94. Use your calculator, that gives negative 2.86. Okay, so the problem now is going to be z to be greater than negative 2.86. So you identify on the normal curve. Okay, it's a negative number, so it's here, negative 2.86, but it's greater than. Remember, greater than means area to the right. But the table will give you area to the left only. So it's going to be 1 minus. You go to the table, remember the table that you use. You need negative 2. This is where we find it. Negative 2.86. So negative 2.8 first. You see negative 2.8 first. Then the 6, 0, 1, 2, 3, 4, 5, 6. 0.0021. Okay, so that give you point. So minus 0.0021. If you subtract it, that give you 0.9958. So the probability that the number of the people to be alive is going to be at least 375. It's going to be 99.58%, almost 100%. So these are going to be the chance. Okay. So if you want to use your calculator, you are going to use it here. Okay. If you want to use calculator, so sorry, you have to use it here. So you use probability that x to be greater than 374.5. You don't need to change it to the z-score. So from the calculator, this means 374.5, the lower, and the upper is infinity, 1e99. So you go to the calculator. You have to do, okay, so this is it. I clear this one, the second, and the 2. Now the lower one is 374. So 374.5. The upper one is different. The upper one is infinity, so it's going to be 1. Remember the E is here, E99. And the rest are going to be the same. Mu of the 400 and the sigma of 8.4. So I'm going down, get the number, there you are, 99.78. This is almost the same, 99.58%, because of those approximations we have. So, we accept both of them. Either one would be fine. If you have the calculator, would be fine to find it, but as I told you, you can use only calculator for calculations. So you get to this part and you write it down for us. But otherwise, it's fine. We can use it, the z-score table, and get all the numbers. That's it. That is, see, as you can see, it's very nice idea, really. That the sample size of 500, and you'll be able to do it without any calculator. And that's a normal approximation to the binomial. In print on your book, you don't have anything. They ask you to go to a special website, but you have some problem sets, 6.6, that I will include that one so that we're able to do it. So one question from this one on the next test, the final. And that's it. We are done with this idea of the normal distribution. So what we are going to do for the rest of the course, you see, now we are ready to do what we promised at the beginning. We promised that what we can do is we can collect the information from a sample and then generalize it, make a prediction for the population. Now we are ready to give you that prediction. So there is an election, you know that the CNN, they collect the information. As soon as you get 2 o'clock, they say, oh, we can project, you know, the guy is winning the election 46%, etc. So you are going to see at the next lecture how we do those predictions. It's going to be quite a nice one and very easy, the cases that we're going to have. Okay, you have quite a lot, and all the questions from the final, most of them are coming from these ideas. Okay, and it's very easy. So we are going to call it estimation. That prediction, we call it estimation. We estimate first, then we challenge it. 2 more concepts, and we do it on time. That's it. Have a good one, and see you on Thursday for the new chapter.